Well, hello there everyone, and this week I got out on my bike and I went through the Valley of the Rocks near Linton, which is a glorious place, and the sun was shining, and this song started going through my mind on days like these, and it put me in a completely different place and made me look at the world in a different way. And that's really relevant to us today, because as well as finding out whether or not any of you could tell me which movie this tune was used as the beginning of the soundtrack to, as the very beginning, as well as that, it would be nice to know if anyone knows who wrote it. But on top of that, it's very relevant because we're about to look at going to the world of logarithms, and in logarithms everything happens a little bit differently. It's the same world, but it's a little bit different. As long as you understand what's going on with powers, it's perfectly possible to do. And it's not necessarily that difficult to get the grasp of what's going on. You just got to be ready for it being different. So we're still in the world of calculus, which is the mathematics of how things change. And the first thing we did was differentiation, which looked at, on a curve, how much the gradient is changing. So it's all about the gradient function, wasn't it? What's the gradient? That's what differentiation told us. Then we did the reverse process, integration, but that didn't give us anything to do with the gradient. That allowed us to work out the area between a curve and the x-axis. Now we're looking at logarithms, which is all to do with how many times something's happening. It's all looking at what the power is, because you can think of the power as how many times something happens. So let's have a little look at this.
Right, so logarithms. Write this down. It's not exactly a definition. Logarithms are a way of looking differently at exponentials or indices. So what's an exponential or an indice? Well, we could have something like 3 to the power of 4, couldn't we? What does 3 to the power of 4 mean? Write it down if you like, see if you can predict what I'm going to do. It means we're doing 3 times 3, and we're doing it to the power of 4, which means we end up with 4 3s. Doesn't mean we're doing it 4 times, does it? We're actually multiplying 3 times, but 3 to the power of 4. And so that was 3 3s are 9, times 3 is 27, times 3 is 81. And let's have a little look at what we call these things. So if we start off with, what is the 3 there? This is, if you're thinking about something like how quickly something's expanding, to put on the real big relevant one at the moment, the coronavirus, at one point it was saying that we had an R rate of 3, so on a daily basis you were getting 3 times as many cases. So if you were starting with that, that's the growth rate. That's how fast things are growing. So you've got 3 on the first, they then times that by 3 gets you 9, and then 27 and 81 and so on. This 81 here is the result. So after 4 days, that's how many people we've got infected. So that's your final result. And what we've got here, the power, that's sort of, you could call it the index, you could call it the exponent, you could call it the power, or you could almost call it time, couldn't you? It's how many times the thing has happened. And that's what we're really interested in. That's what we use logs to look at it in a different way. I don't want you to worry about exactly why we write what we're about to do now, but it does, just trust me, have many real applications. So what I would do for this is I would say log, and then I would put my growth rate. I'm thinking of that as my base. So log base 3 to get 81, and the answer is how many times that's happened. So the power goes there. So that's what we would write for there. So if we had a couple of others, you might want to consider what would happen for 3 to the power of 0. Okay, so it would be 3 to the power 0 is equal to 1, isn't it? So we would have log 3 to the base 3, 1 is going to be equal to 0. So the log for any base of 1 is going to be 0, because whenever something's to the power of 0, it is 1. So think about that, because that's one little law of logs that's just popped up already. And what it's really saying here is that it doesn't matter what you've got. If you do something no times, you've still got 100% of what you had at the beginning. You still got what you started with. So the number of cases you had at the beginning, if you don't have any time, well, that's not going to change. So that's why it's 0. It's the amount of change that we're talking about. And then we could also have what's going to happen with a negative. So 3 to the negative 2, for example, is 1 over 3 squared, isn't it? Or 1/9. So how would we write that? The base is still 3. 1/9, and we'd normally put that in brackets so we don't get confused at that point. That's where we're ending up as our final result. And how many times would we have to do that? We'd have to do it -2 times, whatever that means. Okay. Now going in the other direction, write these down, have a little think. Do you think you can do these? If not, so pause it, have a go, and then watch as I go through, check what we've got. So what we've got is we're saying the result is 32. So I'm going to start this one off by writing equals 32, and I'm saying 2 is my basic number. So 2 to the power of what equals 32? Well, 2 times 2 equals 4, times 2 equals 8, times 2 equals 16, times 2 one more time gets us to 32. So what have I got there? 1, 2, 3, 4, 5, 2. So I've done 2 to the power 5. So 2 to the power 5 is 32. Part B, let's go again. So my final is 0.25. Now, I would say straight into a fraction at this point. So 0.25 is going to be what I want. So I want a quarter, and I'm saying 4 to the power of what is going to be a quarter. And you might even want to just put that down as you're working it and think about it. Well, this is where we get negative indices coming in, because 4 to the power -1 is 1 over 4 to the power of 1, isn't it? So it's 1 over 4. So 4 to the power -1 over 4. On to C. I want 4 log of 0.5. Again, I would say, right, so my base is a half, and I'm thinking, what am I going to do for a half to get there? Well, if I'm going from a fraction to a real number, it's going to be an inverted thing, isn't it? I know that, so 1 over 2 to the -1 is going to be 2, isn't it? 2 over 1. So then if I want to do that squared, that's going to be to the -2. So it's half to the -2. And then D, and the value of, because the value of our answer is 32 really. Carrying on. Oh, now what's going on here? We've got the same letter, haven't we? Well, let's just do the same thing first of all. So we know the result is a to the power of 5. And we're looking for our power here. So all we're saying is it's going to be a to the, oh, that's got to be the same thing, isn't it? So our answers are our powers. So on all of these, the final answer there, log 232 is equal to 5. my final answer here, log 4 0.25 is equal to -1, because that's the power that we were raising it to. Here it's log 0.54 is equal to -2, because that's what we worked out there. And here log a for a to the power 5 is 5, because that's the power that we would have to do to that to get to where we were. Right, so final part for today, using your calculator. You may have thought, oh, why are we doing all of this without using a calculator? Obviously you'll have the calculator in the exam, but if you don't understand what the log's telling you without a calculator, then it's not much use. But we have to deal all the time with the fact that most numbers are not a specific power of something. So 3 to the power of what is 40 is what this is asking us, isn't it? And we can't do this. Now, if you hit the log button, that's only going to be useful for part C, because if you hit the log button, it automatically goes for base 10. So that's powers of 10, 10, 100, 1000, so on. So if I hit log 75, that gives me 1.87506, which will be the answer to that. Now, I only say that now because I'm going to show you how to do all 3 of these for any base now. So the first thing you need to remember is don't go searching all over here all the time, because it's not going to help you. Hit maths. And if you hit maths, you might notice it says log AB. Then hit F2, because that's where log AB is. And all you got to do is stick 3 in there, 40 in there, equals 3.357 or 358 to 3 decimal places, isn't it? 3.358. Next one then, log E. Now, does log E mean any number? No, it doesn't. We got into number E recently, didn't we? So where is E on calculator? It's just there, isn't it? So I have to hit shift and then e to the power x. I just want e, so at this point I need to put e to the power of 1 in there. If there's any way of doing it where you don't have to do that, please let me know, because that's what I've been doing all the time. And then pop 8 in there, and you get 2.079 to 3 decimal places. 2.079. And the final one, you notice we've got 1.875 up there and we did it that way. So let's just check that that gives us the same thing on here. We go log base 10, 75. So 10 to the power of 1.875 is indeed log 10 to the 75. Okay, so all we need to do now is practice some of that. So we're looking at exercise 14D. Now, if you like, if you've got time, by all means do the whole exercise. I don't think it'll do you any harm. It's one of those things where it's a new notation, new way of looking at things. The more you practice it by rote, almost just to get it into your head so you can do it really quickly, the better. But I certainly want you at least to do question 1, 2, 3. There's quite a few questions on those. Then for a little bit of calculator practice, question 5 and question 7 and 8, which will get you thinking about a couple of the rules of logarithms that are going to be important next time. Well, I hope you all enjoy that, your first little foray into the wonderful world of what Mr. Cooper would call Logland.